Hi everyone, I'm Ginny, Assistant Professor from Information Technology. For this video about operating system, course outcome one, understand the various scheduling algorithm and process synchronization. Course outcome two, analyze and contracts to deadlock prevention and avoidance algorithm. Course outcome three, compare and contracts various memory management schemes. Course outcome four, understand the functionality of the file system, input output system, and virtualization. Course outcome five, compare iOS and Android operating system. Syllabus covered. First unit fully introduction about operating system. Unit 2 about process management. Unit 3 memory management. Unit 4 storage management. Unit 5 virtual machines and mobile operating system. In this lecture, we are going to see threading concept. First, what is threading? Threading is a technique that allows a program to run multiple tasks, that is concurrently with the same process. Each task runs a separate thread, but they share the same memory space. A thread is the smallest unit of execution inside a process. Process process is a running program or execution program. For example, Chrome VS Code. A thread is a smaller task inside that program. For example, a web browser, one thread loads the web page. In another thread plays music, and another downloads files. Why use threading? Perform multiple tasks at the same time in improve your application performance. Handle background tasks, that is downloading, logging. So like this. Then types of threading. We have two types of threading: single threaded threading and multi-threaded. Single threaded means it will only one task runs at a time. Example, we want to print a task 1 and task 2. It will task execute sequentially. That is called single threaded. Then how threading works? So multiple threads live inside one process. They share code, heap memory, and they have their own there is having own stack registers. Then types of threading: single threading, multi-threading. Threading one task at a time, and multi-threading. Multiple threads can concurrently within one process. Next, life cycle of thread. There is five life cycle of thread. One is new thread. So now thread is creator. Runnable means ready to run. That is ready to execute the program. Running. Running means currently executing the program. Then blocked or waiting. So waiting for resource. For example, for a input output device. For waiting for resource. Then terminator. Terminator means finish the execution. Then multi-threading models. Multi-threading models define how user level threads are mapped to kernel level threads. So, for example, one to many, many to one to one, many to many, two level model like this. So, many user threads means one kernel thread managed by user level thread library. The diagram shows user level thread models. So, many to one kernel and shared many to one thread. Then one to then many to one. Then two level. So there is having user space and kernel space. Then user level thread, kernel level thread. This is also types of thread on two types: user level thread and kernel level thread. So user level thread is there is no relation to operating system. Kernel level thread is a operating system thread. Then many user thread. Many user thread means many kernel threads. Kernel decides how many threads run simultaneously. The threading improves performance, but it's also introduces several synchronization and coordination problems. That is, if I want to sharing some variable, so variable block, there is a thread zero means there is a thread one means thread and thread zero and thread one. It will improve, but it introduces several synchronization and coordination problems. Here is the kernel decides how many threads run simultaneously. Then, when two or more threads access shared data at the same time, and the final results depends on execution order. For example, two threads incrementing the same counter, that is incorrect value. What are the solution for this threading issues? For semantics, deadlocks, semaphores, synchronization. All the techniques are is having in the this problem. Then deadlock. Deadlock means the resourcing. It will share the two resources in the same time. The deadlock may be occur. First thread is sharing resource waiting for resource one, and a thread one owned by thread two. It's waiting. It's also waiting for resources. So in this time, the deadlock may be occur. Then condition for deadlock. So circular wait. R1 resource one process one resource two process two. The circular wait. Rn is held by it is waiting for run R2. R2 is held by PT is waiting for R2. It only happens when there is a process which are waiting for other resources to finish. Threading issues are problems that arise due to concurrent execution of multiple threads, including race conditions, deadlock, starvation, lifelock, and synchronization overhead. Thank you.